So in this video, we're actually going to go over the skills that are fundamentally important for AI development in the current landscapes. So we're going to actually talk about what actually is context, how context is actually linked to performance, and also understanding how agents are configured differently for different AI tools and how this actually affects outputs. And understanding this is quite crucial if you want to use this forward. We'll also talk about how important context is in the grand scheme of things and show you the examples why it really matters. We'll also talk about how to manage multiple AI agent systems. And we'll also talk about how you can pass context from one agent to another and what is the best way to do so. And lastly, we'll talk about context management and how you should all think about combining this all together as one moving forward. All right, just to show you everything quickly in action, I'm just going to be looking at my old website here. I haven't done any development on it for a very long time, so I'm going to use this as an opportunity to just quickly go through what is here and what improvements can I make. Essentially, I'm going to tell the main agent to review the website. I'm going to ask for improvements, and then we're going to split it into tasks and use sub-agents to quickly make some amends. So let's just do that quick. All right, so I actually want you to review this whole repo here. It's actually for my personal website. I think it's very out of date, and I would really like to understand ways I can make it way better in terms of how it looks, how it feels, make it more modern, and maybe some of the descriptions might be a bit old. So we need to think about improving that. So maybe put a task into that. But this use multiple different sub agents, maybe use one sub agent to directly understand what the site is about, another one to understand the styles, and we could probably do one last one to look at modern ways to improve the site. So let's use 3 sub-agents just to do these findings for us. It should report each finding into its each finding should be reported back to you. And then from that, we can then make a plan and then make that a context file. And then we can then decide what to do from there. All right, so it's going to hit off, and hopefully it'll start using different sub-agents here just to do multiple different ones. So you can see here, it's just trying to understand the structure first, and then it will then report to 3 different sub-agents. So we can see we're trying to keep our main context low here. So you can see it's at 13,000, and now it's got its rough thing. So now it is delegating to 3 different sub-agents to then explore and do each of our tasks that we just mentioned here. The benefit of this is I'm getting a lot more refined information back because each of them are doing their own thing. So if we just jump in, we can see this one is analyze the context of this, provide, context freshness, things like that. If we jump to the next sub-agent, this one would be, let's just go to the top, comprehensive overview of the project structure and technology stack. If we jump to the last one and we go to the top, this is back to the main agent. And this one is, searching for the personal branding, context session, blog newsletter, things like that. All right, so we can see we had 3 different sub-agents run. It got back all this information, and we can see there's some major credibility risks here. Interesting, I don't think I had. All right, so we can see here there's some fake things on the profile. I didn't even know that was there. So I think it's some icons there for companies. All right, so we can see it found a lot of different issues here. And then it's also giving us a plan on how to proceed. So I'm just to say, all right, this is great. Make all of this into a planning document, put this in .temp, and then actually put it into a folder called planning and make this context file have the correct planning information, give all structured information and relevant context files that will be used in this planning for each section and each phase. Really make this plan not verbose, but concise and targeting the right things and performance so we can really refine what we want to do here. All right, so now we're just telling it to make our temp file and then just put our context in. Again, you can see we are keeping our context very low. It's only at 33,000 here. And if we actually had to jump through our sub-agents quick, we could see, the one sub-agent just went to 40,000, one went to 31,000, one went to 29,000. So if we wanted to calculate all that together, we'd be way over 100K already. So you can see it's made its planning doc here, which is great. And I'm going to do one last thing here. So we've got this And now I'm going to say, I'm going to tell it to actually pass this to a task manager agent to then break it into further tasks. And then we can see if we can do this in parallel. All right, so this is great. Can you pass that planning document to the task manager agent? We now want to break this into subtasks and want to understand what things we can actually do in parallel with each other and what batches we can do to execute this. Proceed. All right, so now we can see the task manager is actually breaking this up. So we'll see the main task getting made, and then it will then break it into subtasks. We can see he has a subtask, and the one thing that we're looking at is this parallel flag, because if it's parallel, we can run different things. And this is really great because when we can run multiple different tasks in parallel, it means we can do work a lot faster. And again, if we just look at what these tasks are, you'll see here it's actually pointing to the reference files. It's not giving it a full-on description. It's saying, hey, this is the acceptance criteria, this is the deliverables, this is the reference file, and this is the context files that you probably need. Like, so it's like code quality, for example, here. And we're redesigning article pages. So it's giving a brief description, not too much, but it's always pointing to the right context with acceptance criteria. We're trying to keep the context as refined as possible. This is the approach I take to get the best performance. Anyway, so let's just jump back to the main agent. All right, so we can see it was done. Now it's just breaking down the tasks. So we got 5 parallel tasks we can do whenever for the batch 1, and then it's got batch 2 to 7, and we can see some of them are sequential, and then we got 14% tasks in parallel. So we can actually use some of this to better off it. But before we actually just run, what does this site actually look like? So I'm just going to do this quick. I'm just going to LSS. Let's just do, I don't know if I can actually do button install here. Let's just see. Nope. All right, so I'm just going to do an npm install, and then I will just run this quick to see what it looks like. All right, so this is the website, very old. I haven't done anything about it in a very while, and we can see, yeah, there's a lot to it that is just missing. All right, so I'm just going to close this. All right, so I'm going to tell it to start. All right, we just tell it to start, use parallel agents where possible. And this is where the benefit of this comes in. We can actually do a lot more work faster with the right context. I'm also going to say, all right, so I'm also going to tell it to do a code review after each batch. You could actually do this per task if you want. You could probably tell the task manager to always make sure a code review is done from the coding agent when it does this, or ask for a review after each one. The way you want to work is up to you. Again, it's up to managing context and understanding the actual patterns that you want to incorporate in your workflow. So let's just quickly see. We can see it's running through quite nicely. All right, so cool. We can see this one's already done. It finished that. We can see this one's done. This one's done. One thing you'll see, it actually does try to use this to actually just complete the task, this other thing, so we can always keep track of what's going on. All right, so we can see now batch 1 is complete, all phase are done. That was really quick. And now it's just doing a quick review, double checking everything. You know, there's no ES length configures, and now it's just asking for 1. So it's saying there's a few minor issues, it's going to fix that, and then it'll move on to batch 2. Again, this will just carry on going until the whole task is done. So I'm not going to keep you for the rest of the video for that whole point. But hopefully you understand how we're actually processing our requests and getting something a bit more. I didn't spend that much time on planning. I would spend a lot more time on planning if you're trying to build a more intricate function. And that's where 80% of your time should actually be once you've actually defined and got your workflows working as shown on screen. All right, so step 1 is actually understanding what context is. So just to make it quite simple is we're going to talk about context window here. And essentially the way you guys should think about context window, if you're not really up to scratch with everything, context window is the amount of memory an LLM has and how much information it can actually store. So think of this as a bucket. The bucket can only take so much water, and as soon as you get to above this threshold, it can no longer take that amount of information anymore, and it's effectively done. But the one thing that is important to understand with context window is how it is built up. So, and some things you can't control is something like the system prompt. The system prompt is something that will be built by, for example, Claude Code. You don't actually have access to change that. That is defined by the developments themselves of the tool, and you have to work with a system prompt. And they might also have some tools, so some system tools that are also defined for you. And both of these are kind of put into the context from the get-go. So you can think about above this line is all context that is taken up before you even send your first message. And after this, you can probably send your own message here, and this will be your user message. So you're kind of filling up that bucket of context. So essentially, that's what a context window is. But the next step I actually really want to talk about is understanding how context is directly proportional to performance. So just scrolling back down here, we can see we got this context window, we got the system prompt, the system tools. Again, like I said, this is defined for you. This could be, this could be about 10K tokens, depending on the AI tooling you're using. They are quite robust because there's a lot of tools defined under the hood for them. You can be looking at about 10,000 tokens just from the get-go. And then your user message will come through. And just to say your user message is like 300 tokens. So as soon as you send your message, you're at 10,300 tokens from the get-go when you're sending your message. But one thing to note is as context increases, performance decreases. So as our context window grows, our performance actually decreases. And we've seen this like constantly for the last 2 years. And understanding this is crucial to context engineering. So the more context you put in, we can expect our agent to actually do worse as time goes if we are filling up the context each time. And this is where things are really important. So to make this very simple, a lot of studies have shown about 70,000. With newer models, I think it's about 100,000. So when you get to about 100,000 tokens, you can see a drop off of 50% of your performance. That's a good rule of thumb to think about. So when you get to 100K tokens, you can think about your LM doing about 50% worse, a worse job. This doesn't necessarily mean it's bad for the process you need. Maybe you don't need it to be 100% accurate. Maybe it's just doing, some writing or anything like that, not actually doing code. And then you don't really mind some variance in terms of that because it's not a super critical task. So you don't need that accuracy. But if you are doing coding tasks, having this understanding is crucially important. All right, so we've understand what a context is, how context window works, how context is directly tied to performance. So now we have to understand how our agents are configured. So this is more about what tool you're using. So for example, if you're using like Claude Code, like I said before, the system prompt you can't change. So you are dependent on whatever system prompt they have and the tools that they've set. You can't change that. Where for open code, you can actually change a lot of these system prompts. You can actually make a custom agent. You can disable things. So you can actually reduce this window a lot more with like open code because you can customize your main agent. And I'm talking about main agents here, not sub agents. If you don't know what that is, we'll jump into more detail in a bit. But this is just essentially when you start your coding. So you can think of main agent like this. When you send your first message, this is like the context that happens. At the moment, I'm using a custom agent in OpenCode, but that's beside the point. All right, so understanding the core behavior of your main agent and the tools available for it is crucially important. And I say behavior here, not the system prompt, because I think behavior is the way that we interact with agents. I like to think of agents as assume that you're in a team at work and everyone at your work has a different personality. And the way you talk to one team member doesn't really have the same effect if you talk to another team member the exact same way. Maybe it's down to emotional understanding, certain words or trigger points, things like that. And you really need to think of agents the same way, or AI tooling, to really understand it's more about behavior. It's more about behavior is the crucial thing, because if you don't know how to behave with it, you can't get the most performance out of it. So just keep that as a note. All right. So now we've talked about if context, we talked about how things work, how certain tools are defined from the get-go. But now we also need to talk about how important the start of context actually is. And I'm not going to go into too much detail, but no, that's fine. All right, so now we're going to talk about, how important the start of context is. What am I referring to here? So in this example, that first message we send, this actually has a lot more weight to it than you could actually anticipate. And this actually comes down to how context works under the hood in terms of attention mechanisms and things like that. But essentially, we know it also works with the lower the context window is, the better the performance goes. So it has a double tie-in here. So the first message that you send, you want to make sure it is concise. It's not taking up too many tokens. It's trying to do the right thing that you're trying to progress as most for. You trying not to do too many things. There's a reason for that, because sometimes you're dividing your resources and you're probably going to fill up your context window too fast. So you want to kind of keep to one task or a set of tasks that are very similar together to get to that result a lot faster without expanding your context window. And remember, I'm not saying, one thing I do want to emphasize is if the context window is 1 million, I do not care. You need to keep to that 100K token limit just in terms of performance output. I've seen this with multiple different models with huge context limits. They just do not perform at that level. The newer models are improving that you can probably go a little bit above 100K tokens, but it's not a safe bet. You really need to refine your process now, because it's going to get a lot bigger and a lot faster as time goes. So please just keep to that 100K. Anyway, so that first initial message that we send, we really want to make sure we're maximizing what we're trying to do with the right context, the right direction, and it is not confusing. This is so important. You can't just give a very bland message and hope it doesn't work. But if you don't know what you're doing yet and you want some planning, I do have a scenario how you can fix that. That'll be coming up next. All right. So we understand the first context is important because of performance and how, the agent then. All right, the next thing I actually want to move on to is actually managing multiple agent systems. So what do I actually mean by this? So remember in the beginning I said, well, if we're using the main agents like for Claude Code, for example, the system prompt is not, we can't actually change that. It's out of our control, we've got no access to it, and some of the system tools. So how do we get around this? How do we get around this problem that we can't actually affect the behavior because it's set? It's set for us and we can't determine what's going to happen, and it's possibly going to change in time. Well, one scenario is we can actually make subagents. So we can actually make our own subagents. And those subagents, we can make our own custom. All right, so with our own subagents, we can actually make our own custom system prompt and our own tools. And this is really important because now we're actually setting the behavior of this agent. So if we pass information to it, we are directly in control of how this agent works. And the other benefit is its context window is empty. So say the main agent over here, we already used up to maybe 70,000 tokens. And if we pass a task from our main agent to our subagent's just starting from how much space our system prompt, our tools, and the initial message takes in, which means it's starting with a higher percent of performance accuracy than our main agent in this instance. And this is what makes subagents so good. It's not the fact that you can just offload work, it's the fact that you can actually customize the behavior, and they're actually operating with an empty context window that you can take use of. And this kind of brings down this, and this actually kind of emphasizes this whole way of working with multi-agent systems. So if you are using Claude Code, for example, and you can't change the system prompt here, you can use your main agent as the orchestrator. And you can start doing your planning with this and then tell the orchestrator to delegate it to the sub agents so you can make use of that empty context window. But there is a catch with this kind of methodology. And the biggest catch is like a broken telephone. And what actually happens is sometimes just because this is filling up and we want to pass information to the subagent, it might actually summarize the information wrong, leave key details, and then pass it to the subagent. And the subagent will then do the task, but because it doesn't have the right information from the get-go, it might drift and it's not quite accurate. And then you start ending up with this weird battle that context is a bit off and everything's a little bit in the wrong direction. And I'm pretty sure most of you have had this issue before. And the way to solve it is a little bit more simple. And that will take us to the next point. All right, and the next point is context files. This is super important. So assume you are using your main agent as your orchestration. What you want to do is you want to make use of writing things to context files. So assume you're planning something and all right, so how do you make use of context files? So assume you're using your main agent to start with and you send a message and any response that your main agent does, you say, I actually want you to write this to, and any response your main agent. So assume you're using your main agent here and you've got your system prompt and you send your message, but in your user message, you tell it, hey, I actually want you to write any context that is relevant to this task to its own file. So you can think of this as a planning doc. And this is sometimes a temporary document, so you don't want to make it permanent. So put it in a location that you can delete later. So essentially you tell the main agent, hey, any information that we're doing, I need a planning doc, which will serve as my context file. So essentially our AI response will always be writing to our context file here, and we'll be updating our docs. What's nice is even though as we are filling up our context window, the stock was actually created when context was lower. As long as we're not changing too many things, we can still rely on the stock for a lot of things. And if you do get to that 100K tokens or you limiting, you're seeing degrading of performance, you can actually start a new session and start using this planning doc that you already built on top of it. I wouldn't recommend compacting. Just so if you guys don't know what compacting is the AI agent will take a summary of all user and AI responses, try compact it into the most useful information, and then start a new session. And that user message will be the compaction message that the AI will use. So it already fills up the context and it might not be going in the exact direction you want. You're kind of relying on the AI agent to kind of summarize everything. And I don't always like that. You kind of want to take ownership of the context you're passing with AI. And that'll be the common theme you will hear from this video. So essentially, while you're building out your context file, so you can say, you're planning, you getting all the details meshed up. Now, this is where the crucial part comes in. Say I want to now use a sub agent to perform a task. I would not send a message straight here. I would send a message referring to a context file. And this is extremely important. Because you can't rely on the AI agent to send always the correct information, you want to pass it a context file that the sub agent can use to fill the gaps. Because that way the context is being delivered in the right format. And this moves me on quite nicely to context management. So assume you're making multiple different plans here and you've got a lot of different docs. So you can say, oh, this feature has this doc, this feature has this doc, and you just keep on making context. Now, if you want to pass this to the sub agent, you're passing too much context. And this is where context management comes in. It's understanding how you're planning and separating things. So you actually could have these three docs here, but you understand that these are for three different tasks. Then you can pass each task to its own sub-agent to run. So you separate it and then you're still benefiting from that context file split and you're still knowing the right context is passed your sub-agents and everything works. And then responding back to your main agent when things are complete. So really understanding how to manage context of how things are getting passed from one to another is extremely important. And if you can't see how context is building up in your AI agents, please just like look for it. So if we just want to quickly jump through it. So for open code, you can see like the context is up here. And for Claude code, you can see the context is down here. So really try to understand that context. All right. So once you understand all these concepts together, it's really trying to understand how behavior and context is handled. And the way I'm talking about this is, so if we are using the orchestration kind of approach here, where we're building our context models, trying to keep context low, and these are our pretty much our save points, as you will, our sources of truth. When sub-agents are replying back, maybe they're pulling up this context and things aren't updating correctly. So what I recommend having is some kind of task file with links to context. So you can start managing how context is happening and how tasks are getting completed. So you never have to worry about the context in the window. You're only worried about the task that's happening. So if you stop your session, it doesn't really matter. You just take care of the task, and this task will be linked to certain context files from the get-go. And you can start doing some very nice things. You can start processing things in parallel and, really refining your system down. But you really need to understand how context is going in and how context is coming out from each step. And what I recommend is if you're using open code, really jump into your sub agents, make sure they are performing how you expect. And if using Claude Code, use the verbose and actually expand the sub agents so you can see what's happening inside them, and really try to understand how the model's interpreting your requests, and is it actually keeping to the same direction, or is it actually drifting? All right, let's make this bigger. All right, so in this video, we actually covered the main concepts I think are extremely important for AI development in this day and age, is really understanding context, how context is passed from one agent to another, how we managing context, and how we can actually use that context to actually get better results as time goes. And again, if you are putting tools in, understand how context is used in those tools and passed from one agent to another. That is the core principle that I'm trying to illustrate here. Anyway, guys, I thank you so much for watching, and I really do appreciate all the support. And if you like content like this, it really helps a lot if you hit that like button and subscribe. But anyway, guys, thank you so much for watching. Appreciate the support again, and have a lovely day. Cheers.